Okay, for our second concept, we're going to look at ions and isotopes. So we talked a little bit before about sometimes when the mass number didn't match the number on the periodic table. If that's the case, we call these isotopes. Isotopes are two atoms with the same number of protons but different number of neutrons. We have ions where we have the same number of protons and different number of electrons. So if we look back at the work that we did before, we noticed that we always said that the protons and electrons were equal for all of these. That's true if it's a neutral atom, but in this case, we're going to look at what happens when they're not the same. So it's going to become either positive or negative. All right, so let's look at the first big idea here. When we talk about isotopes, we have this notation here. This is just telling us the information. So we have a total of two numbers, one on top, one on bottom, and then a symbol. So you can see this example here matches kind of this format. So this first number at the top is what we call our mass number. It's the number of protons plus neutrons. So if we were to try to diagram this, what is this element? Well, we know this element has a mass number of 63. The number along the bottom is the number of protons. So the number of protons is going to be equal to 29. This is our atomic number. So the atomic number is there. We can check our periodic table and see that element 29, the atomic number 29, is in fact copper. So copper has an atomic number of 29. It's got a symbol of Cu. And if we look at the mass here, it's 63.55. Here they say it's 63. So this is an isotope. It's a different version of that element. So when we're looking at the name Cu, we can just double check. Cu is going to be copper. So copper is our element. Okay, to find the number of protons, neutrons, and electrons, these are pretty simple. We know that the number of protons and electrons, this is going to be our atomic number. So the number of protons is always equal to the atomic number, so it's going to be 29. So for electrons, this is neutral. We don't have a plus or minus here, and we'll see that later. So neutral, it's going to be the same as atomic number. So our atomic number is 29, meaning these have both the same thing. Okay, to find neutrons, what we're going to have to do is we're going to have to go back to what we know about the atomic mass. Looking at our previous notes, we can see that the number of neutrons is the mass number minus atomic number. So we can write that down here. The neutrons equals our mass number minus atomic number. So in this case, we have a mass number of 63 and an atomic number of 29. So for our neutrons, it's going to be 63 minus our atomic number of 29. So 63 minus 29 would give us our total here. So 31 would make 60 plus 3 more, so we should get 34 for this. So the number of neutrons in this element is 34. All right, so that's how we look at an isotope symbol. Isotopes can be written a different way. So if we look at this here, this is an isotope. This is oxygen 40. So oxygen 40 is an isotope of oxygen, and this is telling us the mass number for this. So if we look at our mass number, it's always going to be given to the second part. So that's the nice part about this is we can see how many protons, neutrons, and electrons there are by kind of reading this out. The mass numbers here. For our atomic number, they don't give us another number. So we have to look at the name of the element. So for the atomic number, we're going to use the element. So oxygen has a total of 8 protons. So 8 would be our atomic number for oxygen. And again, our element name for this is oxygen. They just tell us that. So we have the element name, we have the mass number, and for the atomic number, we have to use the element name. Oxygen has 8. All right, when we're solving for this, again, the number of protons is going to be our atomic number. The number of electrons is going to be the same So this is neutral. So it's going to be the same as protons. So the top here, this is the atomic number. All right, and then the last part, to find the neutrons, we're going to subtract. We know neutrons is mass number minus atomic number. So neutrons is going to be equal to our mass number, 40, minus atomic number of 8. So we should get a total of 32. All right, and that's it.